optimize the traffic jam situations. Then what will be the optimum signaling systems or intelligent smart intelligent signaling systems? Go for the GPS navigations through the help of the satellites. See the entire city map and roads and collect the data on which road, what is the amount of traffic is there, and which roads are less traffic, which route is more traffic, and which route is connecting to which other route and where the junctions are. If all this data is collected and analyzed, it is centered, that can be communicated back to the vehicle users. Then obviously you can go through the routes where the less traffic is there. Of course, nowadays the navigational system is being embedded into the cars nowadays, right? But even it is a bigger cost nowadays. Something is to be contributed more for getting a navigation system in the cars. But in the future, if the IoT is possible, then even in the bicycle there may be a navigation system because of the cheaper IoT technology when it comes in the large scale. Or even on your motorcycles, along with the speedometer and the energy meters, you may have a navigation display also even in the two-wheeler motorcycles, right? So IoT is reaching very well. That is what the vision says. Next go. So smart manufacturing and industrial IoTs. You see here generally in the manufacturing industries also these IoT initiatives they are thinking of much because of the automation of the process. Fortunately, from the industrial revolution, the automated manufacturing industries were there nowadays. Is it clear? Will you observe or will you watch the Discovery channels? Even the Lays and Kurkure, they are manufactured using the automated machines. There will be robotic hands, the entire process will be automated. Is it clear? Then, please move to the next slide. And you see this is the smart city concept. Multiple scenarios you can apply on the smart city, something like healthcare, something like home appliances control. The previous all applications you may apply on the smart city scenario. And even the smart intelligent traffic signaling systems, whatever the previous, some of the previous examples that we have discussed can be overlapped onto the smart city applications. You see, so some visualization, if it is a smart city, then what kind of applications you may go for. Right? And smart cities, some extension was there. Next, go to the next slide. Next. And you see this smart farming and food security. So even if you see those who are at least did some literature survey, something like regarding the wireless sensor networks applications, the agricultural field is one of the major fields for the application of wireless sensor networks. Nowadays, you know that different kind of sensors are there for measuring the physical quantities, right? Something like temperature, pressure, humidity, smoke, fire sensing, whatnot. So there are so many kinds of sensors for sensing almost all. So here it is smart farming. So here this IoT can be extended to the farming also, where you can deploy the field level networks or the building blocks or the local infrastructure, what I am using the terminology so far. Something like you can establish a sensor network in the field. Suppose there may be some diseases time to time will be affected the crops. They can be predicted. How can you predict a particular disease may be affecting that particular crop in the field, right? So every disease there will be some symptoms, like suppose we are going to be sick. We will get some initial symptoms. After that we will become sick, and that will be confirmed something, diagnosed something, and treatment will be given. Similarly, if you see the crops, so it can be predicted. Some sensors can be deployed in the fields, and some parameters can be sensed. Something like humidity, suppose the temperature, and the pressures in the field, that can be, the data can be collected through the sensors, and that can be processed, and that can be compared with the heuristic data, and a conclusion can be made in that particular field. So this is the humidity, and when that particular crop is there, if this is the humidity level, definitely that particular disease may affect it. So from the data analysis it is possible. Then the precautionary measures may be suggested to the farmers. Is it clear? Until waiting, that crop is waited and going for the later stage precautions or measures, we can go for the precautions. Next. Right? So far, monotonically I am going on, but I hope because the time limitation is there, so I am slowly moving on. So far we have seen something like the statistical data, what is IoT, IoT structures, and the applications of IoT and other things. Now, as already I have given in my discussions, that is this IoT can be directly connected to the internet, means not possible, because the internet technology is different, its policy, operating policies are different, that infrastructure is also different. And when you come to the IoT devices, the virtual and physical devices, their technology, their computational capabilities, okay, their storage levels, their computational levels, application levels are completely different from the internet infrastructure. So that's why whatever the physical and virtual devices you are claiming under the IoT, you cannot take them and directly connect to the internet. Is it clear? So to make it simple and to minimize the communication delay to communicate the computed data, so this particular concept was that. So some technology is required that directly supports the end user devices that we are claiming under the IoT. Right? So that's why you see this is the structure where, so data center at the top you see, otherwise you can move from the bottom to top. At the top there is a cloud, and below the cloud there is a fog, and below that we have this our IoT, these things. Of course the mist is also extending. So but the scenario I have given, in the core cloud will be there, at its edge. The edge infrastructure of the cloud can be used for the fog computing. And on the edge of the fogging or the fog network, still you can use for the mist computing. In the mist environment, of course, we will be there. So this is where the technological support will be available for the IoT devices. One thing. That is the technical feasibility. Okay. In addition to that, we have the advantages. What are the advantages? See, for a simple computation, you need not move or you need not make a transformation of data from the end user device to the inner core of the network, that is the cloud. And again you have to come back for a simple calculation of the computation. So in the distributed environment, distributed environment, distributed operating system, its functionality. In the distributed environment, which is a software concept over the hardware networking infrastructure. What is the distributed networks or the distributed environment? It's a software approach built over the existing network physical architectures, right? So if you go for the IoT in the distributed architecture, you can use the maximum level of local infrastructure. If and only needed, then only we will move into up to the cloud. Otherwise, you can make the things done at the user level infrastructure. So that is the major advantage. And one more thing is, because of the wide variety of the IoT devices, we cannot make the compatibility with the existing backbone internet architectures. So that's why something else, some additional infrastructure should be proposed for supporting the wide variety of IoT devices. So that's why these intermediate layers we got, and this fog and mist layers are coming to picture. So the same thing, this is also shows how the fog computing or the mist or the IoT and the cloud were integrated together in a single architecture. Next. Now let us move at a glance, so there are so many benefits. Is it clear? There are so many benefits of the IoT as we are discussing for the long time. Suppose you see, so what are the potential benefits if you can see? So key changes in the industry. See the first column, second column, and what are the benefits. So this is suppose like something healthcare, manufacturing, retail, and automotive and transportation. There are various sectors. In that, if you could make some significant changes because of these IoTs, then what are the advantages you are going to be? Suppose something like you see healthcare. So remote monitoring of staff and patients, ability to locate and identity status of the equipment. Just a few minutes ago, I gave an application. No? Suppose sensing some data from the human body, then sending it to somewhere, analyzing somewhere, getting the reports back, and giving the treatment. Something like advantages will be there. Next, we can move. And somehow I think these slides will be available. Those who are interested, you can refer these slides. Because of the time limitations, I am skipping. And just you please stop here. You see this, the industries with most to gain from the IoT. Suppose at a glance, something like. You see suppose here, so manufacturing industry or the manufacturing sector, retail trades, finance and information services, as well as the other sectors. Contributing, just you see the percentage. So manufacturing sector is going to be benefited, much benefited at 27%, and something like the retail trade sector is going to be benefited 11%, and this finance and insurance 9%, and the information services 9%, and all other sectors together they are going to be benefited around 44%, right? And you see, if you see that, and there you see the contribution in terms of the amount, that is the money, also that was specified there. You see, the manufacturing industry is going to be contribute in the form of the IoT services around $3.9 trillion. Okay, these are very authenticated estimates by the authorized organizations. Okay, something like you see retail trade, it is $1.6 trillion. Similarly, if you see the finance, $1.3 trillion, and information services about $1.3 trillion. Similarly, the other altogether $6.3 trillion are going to be contributed in the form of IoT services. So that means how much market is there financially also. Is it clear? How much market is there for the IoT? Next one. And you see these are some challenges of IoT, of course, how the Internet of Everything was integrated in one figure. I think the time is running out. So this is the Internet of Everything, how suppose the people, things and the data was integrated with the different sectors like home appliances, mobiles and business, and the various stakeholders in the Internet of Everything. And on the right hand side you see, of course it may not be visible, but there the Cisco estimating that as per now, that means in the current scenario, even 1% is not yet connected to the IoT. So already we have seen some statistical data, no, billions, millions, something like that. But Cisco is saying that out of all this existence, the current status of the IoT, Cisco is saying that even 1% is not connected to the IoT. Then see how much more left over, something like 99%. Then what is the open-ended opportunities, research opportunities, business opportunities, and others, right? Go to the next slide now. So obviously, when we are discussing all these things, there will be some challenges but of course in my discussion, they were covered: the security, privacy, then adaptability, reliability, and quality of service. Reliability, you can, one point to notice, that is dependability. Is it clear?